Welcome to Aerodynamics in Minutes. We are going to see what is divergence and what is curl. You can see that at some point the fluid seems to spring into existence from nowhere and some points acts like sinks. The divergence at a particular point tells us how much this imagined fluid tends to flow inwards or outwards. At a point, if the fluid flows outwards, has a positive divergence. On the other hand, if the fluid flows inwards, has a negative divergence. The divergence of a vector field is a scalar quantity. To write it mathematically, let us take a one-dimensional vector field. To know the divergence, we need to find how the fluid varies with respect to x, since we are talking about one dimension. For example, 20 packets of fluid coming in and 20 packets of fluid are leaving, the divergence of the vector field is 0 for this case, since there is no extra packets popping up. In this example, the fluid flow is defined by a vector field equation, and I made other two dimensions 0 for easy understanding. The x component of the divergent is a partial differential equation of the x component of the vector field with respect to x. Similarly, for other two y and z components is how the y and z component of the vector field varies with respect to y and z. For example, let us take the center point of the flow. 20 packets of the fluid are leaving in minus x direction and 20 packets are leaving in x direction, and the total packets leaving is 40. And the sum of how x, y and z component varies is called the divergence. The divergence tells us how much the point acts like a source or a sink. It don't particularly needs to be in the fluid alone. It can be in any vector field. For example, the magnetic field lines start from North Pole and ends at South Pole. Measuring the divergence at the North Pole tells us how strong the magnetic field is. Curl of a vector field measures the magnitude of the rotation of the vector field. The direction of the rotation is given by the right-hand rule. To get intuition, let us assume there is a circular flow. We can easily say we cannot use the flow directly, and we know that curl gives the magnitude of rotation, and the magnitude is represented in the third direction. Now, if I place an object inside the flow, the curl will give me the magnitude, how much my object will be accelerated to rotate. In this example, you can see that stream at the middle moves faster and the stream at the end barely moves. This causes a gradient of velocity stream. If I place a leaf at the circle, the leaf will rotate. You can see that some of leaves in the gradient part of the stream are rotating. To write the curl mathematically, let us take a rotating flow field. Moving along in y-axis, the magnitude of the x component of the flow field changes from positive to negative, and moving along in x-axis, the magnitude of the y component of the flow field changes from negative to positive. I have mentioned some random magnitudes to make it easy to understand. We need to find the difference in magnitude. If both the start and end point has the same magnitude and same direction, there won't be any rotation. In our case, along y-axis, it starts at minus 20 and ends at plus 20. The difference is minus 40. Along x, it starts at 20 and ends at minus 20, and the difference is 40. Now, we need to introduce negative sign extensively to make these two magnitudes add up each other. If we don't put the negative sign there, they will cancel out each other and we cannot find the magnitude of rotation. The magnitude of curl in xy plane is represented in the z direction, and for zy plane in the x direction, similarly xz plane in the y direction. The direction is given by right-hand rule. The magnitude is positive or facing in the thumb direction if the curl rotates in the same direction as our finger rolls. Similarly, if we continue the same for other two zy and xy plane, we will end up with the three magnitudes in I, j and k direction. We can write this in a vector form. Total curl is equal to curl of yz plus curl of zx plus curl of xy. And once again, what it tells us is the magnitude of rotation of the fluid. If I place an object inside the flow, how much my body is affected by the flow given by the curl. This equation can be rewritten easily into corresponding components, where F is the flow field, and this can be easily written into cross product. And on another real life example, the curl gives the magnitude of the airflow around the globe. If the magnitude crosses a certain level, it is called cyclone. If you didn't understand, go and check out the videos in the Khan Academy. I will leave a link in the description. Thank you for watching. This is Dianish signing off in Aerodynamics in minutes. See you in the next video. Stay tuned.